Explanation of Boolean indexing behaviors. For the 2D array Y, all indexing select first, third, and fifth rows. This is clear. Questions? Please help understand what rules or mechanism are working to produce the results. Replacing with tuple produces an empty array with shape 0, 5, 4. Use single true adds a new axis. Adding additional Boolean true produces the same. However, adding false Boolean causes the empty array again. Not sure the documentation explains this behavior. Boolean array indexing. In general, if an index includes a Boolean array, the result will be identical to inserting up non-zero into the same position and uses integer array indexing mechanism described above. X and underscore 1, Boolean underscore array, and underscore 2, is equivalent to X and underscore 1, plus Boolean underscore array dot non-zero plus, and underscore 2. If there is only one Boolean array and no integer indexing array present, this is straightforward. Care must only be taken to make sure that the Boolean index has exactly as many dimensions as it is supposed to work with.
Boolean scalar indexing is not well documented, but you can trace how it is handled in the source code. See for example this comment and associated code in the numpy source. So if an index is a scalar Boolean, a new axis is added. If the value is true, the size of the axis is 1, and if the value is false, the size of the axis is 0. This behavior was introduced in numpy number 3798, and the author outlines the motivation in this comment. Roughly, the aim was to provide consistency in the output of filtering operations. For example, the interesting thing is that any subsequent scalar Booleans after the first do not add additional dimensions. From an implementation standpoint, this seems to be due to consecutive 0D Boolean indices being treated as equivalent to consecutive fancy indices, i.e. has underscore 0D underscore bool is treated as has underscore fancy in some cases, and thus are combined in the same way as fancy indices. From a logical standpoint, this corner case behavior does not appear to be intentional. For example, I can't find any discussion of it in numpy number 3798. Given that, I would recommend considering this behavior poorly defined, and avoid it in favor of well-documented indexing approaches.
If you want to say more